Thank you for joining today. This is Brenda Kevorkian, your host. With me today, I have David Barron from the R&D team, and David will go over the SMAX machine learning topic today. So, David, please take it away.
Okay, great. Thanks for the introduction. And indeed, today we are focusing on the topic of artificial intelligence and machine learning. And when we go through this, there's three sections. One is just to go over background on just, more on a high level. What do we mean when we use the terms artificial intelligence or machine learning? We will then bring that within the context of SMAX to look at a tour of different features that are using these kinds of innovations and technologies. And last but not least, maybe the area that will be of lots of interest to those of you that have been using SMAX for some time is some hints and details on configuration and administration that relate to a few of the key features that utilize our machine learning functionality. And this, of course, is just part of our ongoing sessions here. I don't think that we need to give that much intro to this, but we use our time for the topic at hand. But we're always glad that you can join us for these very dedicated sessions on different areas of interest. And with that, let's look at, as I said, the first area here, which is just defining what do we mean by AI or machine learning. They are terms that have been around for quite some time. In some ways, they become buzzwords at different times and decades, and become fashionable. And certainly these days, machine learning is a term that we hear about a lot. I remember AI as well, and things like expert systems were hot in the late 80s and early 90s, and they came and went. But all these terms, as they come and go, in some ways refer to various things that really are relevant to the technology that we're using in SMAX. And the definitions I have here, just to give just a point of context, even though back in my college days, my particular study of focus was cognitive science and artificial intelligence. Things have changed a lot since then, but we have experts on our R&D staff that are very versed in the latest PhDs in these topics, and I've collaborated with them to get a lot of information that I'm showing here, just an introduction. But I'm for sure not the very latest expert on each of these definitions, but want to bring them here in light of terms like artificial intelligence, which we see intelligence exhibited by machines, certainly machine learning, which is all about, as we would expect, smart programs that can learn from examples or observations of things that are happening in a system and improve and make certain decisions or classifications based on that learning. But there's other things that also may fall under this area of artificial intelligence or AI. Deep learning, for example, is a term we often hear as well, or sometimes it becomes a buzzword, and it's just more of an overarching architecture that is incorporating a number of different innovations or technologies. Neural networks, back again in the 80s were quite big, something inspired by the way that brains seem to work at the connectivity of neurons, or our cognitive computing, where we simulate human thought process in a computerized model. Expert systems in some ways were early versions of these cognitive computing models of trying to mimic decision process that humans use in a computer program. So I bring these definitions up because in reality, I think when we use the term machine learning, we're really overlapping many different things that really at the technical or academic level could really fall under different categories. But that's just as an aside, but I like to point it out as well, because sometimes people may be confused. Well, what does this term mean? And different companies may be using it a little bit differently, and it evolves. But really, there's many different terminologies that that may blend or that may be applicable to what we're talking about. What's more interesting here again is the types of things that these technologies help us with. And these are different tasks, again, at more of a definition level that often associated with machine learning. Things like classification is an important intelligence task. We see it in things like our smart ticketing classification that we'll look at in more detail in this presentation, where we can look at certain records, automatically classify them in terms of their categories or the kind of groups that should work with them. Those are classifications that are learned from different observations and machine learning algorithms. Regression tasks as well, where we can look at, let's say, different patterns in data, number of incidents that have been created, and do some regression learning to predict what may be happening in the future, the kind of tickets that we may see in different categories, or the smart change analytics that we have in SMAX that many of you may be using or are familiar with, where again, there's regression learning from the way that certain patterns have occurred in success or automation and time that it takes or risk that it may involve executing similar changes. Clustering tasks, very important type of machine learning that we apply in our case in hot topic clustering and finding patterns that may occur in descriptions or searches involved with what users are doing in the system. Transcription tasks, these would be well exemplified by looking at digital data, like what we have in images that are optically looked at, analyzed, and then used for classification of smart tickets. Machine translation, you obviously, probably many of you have used translation tools like Google Translate, which we use internally as well for on-the-fly translation of conversations between users and agents, or on-the-fly translation of knowledge content. That's powered by true intelligence that is now leverageable and almost becomes ubiquitous in the way that we're used to doing web browsing. So very important technology we use. Structured output, where we can do, this is maybe more related to things we may do in the future, such as sentiment analysis, looking at, let's say, patterns that we have and output that into structured classification or analyzing the sentiment of what we see being passed in messages or comments, profiling users according to their expertise. There's another example of something we can do there. There's a little noise on the line. I don't know if people can mute to themselves. We'll have a clearer recording and sound. That would be great. Anomaly detection is something we may look at into the future. Being able to detect that there are certain cases that represent anomalies and they've been classified, let's say, as major incidents, and detecting those automatically when we see a certain pattern and say, oh, this doesn't fit, normal type of instance we see, maybe it reserves a certain major incident classification. And then synthesis and sampling, there's some technology we have looked at internally within Micro Focus that we could leverage for things like text to voice, so things that we consider sometimes that use this kind of technology, or our virtual agent and things that we're doing there in upcoming releases. We'll use some of this technology for even smarter conversational responding. So we have some examples here that I've mentioned of tasks, and we can go on. I will actually kind of skim through some of these things because I want to get some of the specifics of features and administration. But again, when we look at the next level of detail, different algorithms that are applied, there are so many different categories of algorithms. You see some here, and I say supervised learning that maps many different, looking at inputs that may come over time and map those to a good output in future cases. An example of that we do today is where our virtual agent may suggest a certain offering to users from the catalog based on the fact that some similar type of wording in other users' requests in the past led to the opening of tickets that then were associated, maybe more manually by an agent, with an offering that would be able to provide the support or service that that user is truly wanting. And the system's learning from that. And so in the future, when you see similar wording patterns, they say, oh, this kind of wording was associated with this offering in the past. Let's just suggest that automatically. So that's an algorithm that's used there. Unsupervised learning is more what we've seen in like hot topic analytics, or finding similar cases where we make suggestions, say in our live support interface, that again is learned from looking at unstructured data, descriptions, titles, and mapping those over to specific structured data that then is suggested, like the similar tickets, or structuring things that we show in hot topic analytics. Let's see what else is interesting here. Reinforcement learning is something that we use a little bit, and we're looking into new opportunities to use this further. For example, when somebody marks certain knowledge articles as helpful or not helpful, and being able to take that as input that will provide, boost kind of ratings and suggestions, and learn what to suggest in the future. That's something that we're looking to put in to activate as an important way of learning, and into our virtual agent flow, things that we started with a POC version and beta version of functionality that will soon be GA and incoming releases on next generation of our virtual agent, that also is taking reinforcement learning on what users are asking for, when they actually are satisfied by an answer returned by virtual agent, or when they're not and they need to go in and open a ticket instead, or ask for something else. That's reinforcement that we can take to over time learn and provide even more accurate conversations and suggestions from a virtual agent. So these are algorithms either that we use or that we will be leveraging. Lots more algorithms that are provided here, probably beyond the scope of what we need to discuss here. But the point here again is that there's been so much research, so much technology that can be leveraged, either some that we've developed in-house, some that we can leverage that's put together right, can be brought in from sources that are available for us to leverage. Here's some more on unsupervised learning algorithms, reinforcement learning algorithms, lots of things to look at. And just as a summary of things that I've talked about to a certain degree, this just gives some of the sampling examples. It's not a comprehensive list or exhaustive list of all the features that we have in use machine learning, but it gives you some idea as well. When we do things like smart ticketing, well, what is behind the scenes there? What makes it intelligent? There's actually a combination of algorithms and technologies that we have put into the system, such as naive Bayes for classification, anomaly detection for adaptive learning, and information theory type of algorithms as well, that all come together to result in what we see in the smart ticketing that we're familiar with. Or even something like CI detection, where you have the ability to analyze text very quickly, detect something that looks like may reference information that could be linked to a CI in the database, maybe by name or serial number, and then making that connection and detecting, yes, this is a CI, and providing that as a suggestion. That's made possible by AI and machine learning algorithms that we use behind the scenes. And again, you can see that in many different cases here without reading case by case. There's a lot of rich technology that goes into putting all the features and functions that we see in the product. So that's just as a quick introduction and context for this very valuable type of technology and use cases. And what I want to do now is look in more detail, just as a tour at AI and machine learning in terms of features that we have in SMAX. And I hope this is useful for everyone at different levels. Some of you may not be aware of every feature that I'll talk to, and so it's just good to know that they're there and something you can try. Or in some cases you may know a feature and you didn't consider that there's some AI or machine learning behind the scenes for that. And in this section, I will simply go over a sampling tour of all these, and then we will drill down into some of them specifically to understand how they work, and to also then look at how you can administer or configure them to work even better for you. So certainly, starting with something as as basic and everyday feature as smart search, there are important elements of machine learning or intelligence that we put in the way that this is used. And of course, part of this is being able to combine a number of different sources that could be indexed, but then brought in together in a smart way and blended in together in terms of returning global results that may be relevant to a user. And so the fact that we can, first of all, have global search over all kinds of different records in the database, whether it's knowledge or requests for support tickets or incidents or changes or data from SACM and CMS that's represented as CIs or services, questions in a forum. There's so many different types of data, all structured differently, and yet they all come together in terms of a single presentation, as well as data that could come from externally indexed systems. So it's very important to notice the fact that is brought in a smart way, and then being able to apply it in a context-aware type of use case, such as a solution to what an agent is looking for, working with a user and a live support is important. So it's not just about having the algorithms for finding the data, but then the design for using it. It's an important part that needs to go together. And then some things that make this even smarter, some of the advanced contextual search features are very important. For example, a lot of these things, just happen automatically. You may not even be aware that they're taking place, but there's context-based search that takes place all the time. Let's say that you are working on an incident. On the right-hand sidebar, there's information about a contract that we have found that may be affecting incidents, affecting CIs that have been identified as affected by that incident, and those contracts show up as well. So well, there's something wrong with this server or this printer, and I actually have a warranty on that, or I have a service contract, and I may need to access that as part of my support or as part of something I'm planning on a change. And if I'm looking at a change, we do similar things for context-based search to find similar changes that I can learn from in terms of risk analysis, or to look at how those were done so I can maybe model the change I'm working on in a similar way. When users are in the portal, on the right-hand sidebar, there's context-based search that is providing perhaps news that are relevant to the topic that I'm searching for, or other offerings that could have been found in the catalog that may be related to an offering I'm already looking at. So those are automatically context-aware type of searches that are taking place within the interface. There's adaptive learning that takes place as well. I already gave the example of when I'm interacting with the virtual agent, and there's offerings that are suggested because there was learning based on previous requests that resulted in using those offerings, and then that's why certain things may be suggested the next time around. Smart language identification is important as well. So I may be searching and searching in English or in Spanish or in French, and finding content that matches based on that language. Also is using some intelligence in detecting the language and then searching in the right type of index based on how you have maybe localized your content. So that's also something we can take maybe for granted that, well, it's just going to work, but there's some intelligence, artificial intelligence, machine learning that enables that as well. The optical character recognition technology that's part of our bigger smart ticketing feature is also important. And this one, in a certain degree, kind of like search as well. You know, these things just work, but we'll find ways that you can fine tune them. And the same thing with OCR. This is something that you don't have to do much or even train it to work. We have technology that can already take a picture, take a, let's say, screenshot with error messages, and find the text behind that, translate it to text, and then based on that, all kinds of things can happen, such as the ticket being automatically classified, associated maybe with an offering that can provide the right kind of support. You're putting a screenshot of an error message that a lot of people are running into, and so it becomes a known type of issue for which an automated resolution offering has already been defined. So just by taking a picture, submitting it, OCR comes in, text is detected, a offering is selected automatically, and maybe you're given a solution without a user on the agent side having looked at your ticket. That's real intelligence coming together from end to end, working together. And so I encourage, if you haven't tried this out, you can do it. The mobile interface is a good way to try this out, taking a picture with your mobile, opening a ticket that way, and then seeing how it gets processed. One thing that we've seen that's popular as well, you're taking a picture of something, may reference a CI, and then you have not only the OCR technology then playing together also with CI detection, so that the ticket that's created has detected a CI referenced in that image and already associated that with the request that you have opened. So sometimes the technology is working side by side together. So that's as far as OCR. Smart ticketing, I've referenced this in my previous example as well, and this is something that I will go into further detail here in the next section in terms of how the algorithms work, how to best approach training. But this is a powerful feature that can learn about things like group assignments, categorization, offerings that are selected for requests that you may open, and automatically fill those in so that something is automatically assigned, automatically categorized, automatically going into a fulfillment of a task on of an offering, simply based on learning of patterns on the titles and descriptions of tickets that are, request tickets that are open. So very, very powerful for automation. And we'll come and visit this again, as I said, in just a few slides. Smart ticketing. Virtual agent and the end user smart chat that is in the portal is something that has been in SMAX for quite some time. And as I mentioned, we have not only a new technology that we've been in POC and beta for now, but also that will soon be available in GA in a coming release that we're working on. All this is about, of course, automating more and more of the conversations between end users and a virtual agent that can provide support before having to actually maybe engage someone with a live agent support chat or a ticket where a queue will accumulate those and get assigned for work. The ideas that we're putting in the virtual agent go beyond, for example, some of the past solution learning that I mentioned already for offerings that are adaptive learning based suggested. But we're also looking at new algorithms that will identify the intent that a user is coming to talk about. And that's very key because different users may describe what they want in very different ways when they're conversing here. And what we want to know is, well, what is the intent? Why are you chatting with the virtual agent? Is it because you need help requesting something, you're having problems with something, you need maybe information on how to do a certain thing? And so once we identify the intent, we can then provide the right kind of suggestions, and the virtual agent can even guide in automatically resolving that. So there's important learning around intent and refining the intent, and then leading that on to having the virtual agent be also capable of executing many interesting actions and providing results back to the user. That's technology that you'll see coming as well. So I just mentioned it here as a part of the theme, and if you're interested in this, just keep your eyes open for what's coming. There's good stuff there. Live on-the-fly translation, I mentioned it as one of the types of technologies that leverages key machine learning algorithms. The truth is here we're leveraging external technology for this. To actually activate this, we integrate with Google Translate. We actually have tried integration with other services as well, but Google Translate is the one that we support from a GA perspective. And it's not just about, this is a great example about, not just about the fact that, Google has developed this technology, so maybe they get all the credit for the fact that it's here, but what's interesting here is how do you plug this in a way that's very useful in the context of a service desk, of, for example, users that may be in a global enterprise, have very different languages, and maybe they're accessing a central IT service desk where most people there may be operating in a different language. Maybe, let's say, English is a standard language or French, but you have users in South America or in Asia that may be putting in their comments or their requests in Spanish or in Chinese, and yet they can interact with an agent, and translation already occurs in the comments and interactions that go back and forth. Or another example, of course, is you may not have translated all of your knowledge base into every language, but somebody wants to search and then look at an article and see it in their own language. It's useful that that's available to them as well. So if this is something you want to leverage and you haven't tried it, you just look in the documentation with a Google Translate subscription, which is not that expensive. You can then activate that, we integrate to it, and make the API calls for the translation to occur. Quickly on the virtual agent-based email integration, all the same ideas that we talked about virtual agent, we put these also to a certain degree now with a smart email, so that we can provide suggestions by email to someone who sent an email-based support. And it's the same kind of learning, adaptive learning would then provide the kind of results that are suggested in email. So it's a different user experience utilizing similar technology that's key here. Very effective way of, again, minimizing manual work and maximizing automation or self-sufficiency. Fast CI detection was an example that I gave before, but if it's something you haven't seen before, whether you're working with a change or an incident ticket, you may have within an interesting description text that we automatically detect. This looks like a CI, as I said, and indeed a match is made, and then the suggestion not only highlights that as a CI, but a database link to that CI is made. So if you look at the involved CIs tab of your change or incident, you will see the CIs that were detected here actually listed in the many-to-many relationships that have been created between the two records. And so very effective, and it's something that comes in very large part due to AI and intelligent type of algorithms that go behind the scenes to make this possible. Hot topic analytics, again, another thing that uses the ability to structure things. And this is interesting because, a lot of times you may see these kinds of categorization type of maps that may not be related to truly a smart, intelligent, discovered type of pattern or hot topics. It may just be a graphical representation of structured data and categories that somebody already manually created. And that's not the same as what goes on here, where there's true intelligence behind the scenes to find patterns, find topics, and then words that match those topics to create relationships between what is a hot topic and then what are the records behind it. And there's many important use cases then that this enables. So this again is another example of machine learning that goes behind the scenes. And this last one that I mentioned here is it's more of a CMS technology type of feature, but it's something that it's part of the suite if you're deploying the CMS and its discovery, and we have the smart automatic software recognition to identify based again on patterns, but in this case of software that is running, what is the classification and what kind of software is this, and maybe determine exactly the determination between products and software based on processes or things that are discovered are installed on the infrastructure. And being able to learn this rather than having to manually define all of the discovery type of maps is a great time saver and value that is yet another way that the technology here provides a tremendous automation. So with that, let's drill down into a few of the special, especially popular areas, popular from the perspective of often the types of questions that we get from those of you that are looking at how to use and leverage this technology, and look at some hints on how they work and or how to configure them effectively. And I will start with smart ticketing because really out of the different technologies, this is one that has some powerful configuration type of interfaces. A lot of the others maybe are more just working as is out of the box without you having to do much. But smart ticketing is one that involves some training and testing that you can control. So smart ticketing, again, as I mentioned, is all about being able to predict and then assign certain values to key fields in tickets. And we have enabled it in SMAX with our request management application around these fields that we show here: categorization, affected services, fulfillment offering. And this is based on activities that first involve the training process, looking at historic tickets to learn how we will be assigning these values, and then a testing process that measures accuracy. And that's something that you control, you run the test, and you can determine when enough training has taken place to put this on, to turn on that automatic classification and smart ticketing into your system. And the way that this works, there's specific configuration and training. I have a system running. I may bring those screens up in a moment. Let me see actually if I have it here. I might have logged out. I wasn't this one. Let me see if I have it here. No, that's okay. We'll just look at the screen and I have a few screenshots of how this all works. But basically, the way that the training works is based on looking at a whole set of records. It could be a subset of the total number of records that you have. In this case, it's request records in your database. As an example, let's imagine we have 1 million request tickets that you're going to use and do learning from. You may have more, you may have less, but in this example, let's say we have that sampling. And from that, in the smart ticketing configuration, you can create a training scenario that will say, I want to train on, in this case, a request module. That's the only module that we've enabled now. We have plans to roadmap to enable other modules as well. You select the field that you're going to train. I want to train on offering because I want the system to automatically choose the best offering for a request based on what the descriptions and titles are about. So that's what I want to train. But then you can say, well, within all my 1 million requests, do I want to use them all? Or maybe, I'm going to maybe refine and only use a certain subset of my records as my training. And in this case, I have an expression here. I'm going to say I want to match the value close for the phase ID of my request. What this means is that only requests that are closed already will be used for the training. Anything that's still open and being worked on, well, let's not use it for training yet, because maybe they're still, they may still be classified differently or solved in a different way. So anyway, you can have different filters here, but this is one of the key things. So let's say once you do that, only, let's say, 700,000 records now are actually closed, and then the others are open, and so that becomes your training sample. There's other fields here too that you can define for refining what you're training on. This is a predicted field query. This is where you put an expression that says, well, what I'm predicting here is my offering. And let's say I have all kinds of offerings in my catalog. I have hundreds of them. But you know what? A number of them are no longer active. They're inactive offerings because they're old or obsolete. They were offerings I used a year ago, but no longer today. So I'm going to make sure that I have a not match with the value inactive in terms of the status of my offering. So now I've filtered. So I'm only looking at request tickets that are closed. And within those, I'm only going to be training those that were associated with offerings that are still active, because if they're inactive, I'm going to exclude them. And I don't want to train that, because something might have been very, very appropriate a month ago, but no longer today. So that's the first set of the values here. Based on that, the smart ticketing algorithm will basically find categorization of all the tickets and frequencies when a certain offering was used. Maybe this one was used a lot, this one less, etc. So it will categorize the tickets into buckets. And after that, you also will still do further refinement, because there may be a lot of offerings that were barely used, maybe a few times, or some were used a lot. So there's something that says source data coverage that gives a percentage. I want to maybe look at only my top 90 percentile of all the requests. And if you make that smaller, then if it's a top 20%, maybe it will just be these tickets here. And you say that's what I want to train on. The rest are not going to be significant enough because they're not occurring that often. And so that's what that's about. There's training samples per predicted field. That's where you can put a minimum value as well to say, for any one offering, each bar here represents an offering. Let's say here's an offering for requesting a printer. I want to make sure that I've looked at least 200 samples of tickets that predicted that printer, to say that I have looked at enough of that. So I want to have at least 200 samples per predicted field. And then the last thing is, this is actually associated, once I've done my training, then you run a testing execution that tells you, now let's simulate doing some prediction of offerings. And so it will select some, in this case, 5% of the records, and try to predict what offering would have been selected, and see if you got it right, if that's the offering that was truly selected. And so that's a test data range that will be used. And based on that, you will get a result that will look something like this, where you have, okay, we did a training on category, we've run it, and it tells you, we got a hit count of 7.69% of the time we got things right. And of course, I had very few documents when I ran this test and put the screenshot, so it's not surprising that I had very low accuracy. I had a very high miss rate. The whole point here is that when you test, you get this scorecard, and then you can decide if this looks good enough. I'm getting, let's say, flip of this. 92% of the time, I'm predicting the right value. Well, let's then activate this training and use it for smart ticketing. And what you can do is run this training test. You can run and test them several times. So over time, you'll have more records. So you can increase the accuracy, the more records you have. And once you hit a threshold that you like, you can say, good, let's activate it. you can also create multiple training scenarios. So let's say that right now you're interested in training on offering. You know that it's going to take a while. I don't want to train on all my offerings, so I'm going to train just on a couple of offerings. Let's say ordering PCs and requesting a new digital badge to access the building. Those happen so much that I want to be really good at just predicting those, because I'm going to automate them and I don't want to do anything manual. And so you could do trainings just on a couple fields with your filters and get really good at that. And later you can train on more values. And so it doesn't have to be an all or nothing, but you can refine and focus this and have a strategy to use this where it's most important. So that's as far as my ticketing. Hot topic analytics. Here, just the main thing I want to mention as far as fine-tuning and algorithms. This slide here actually just talks about the algorithm that we use behind the scenes for this. It's an interesting algorithm that basically will look at whatever document. Let's say it's a request ticket that we're going to categorize into hot topics, and it starts creating a list of topics based on words or phrases that occur. There's these patterns in looking at a number of such records. And then it goes through really a random way of assigning, well, what other words are occurring in that document, and saying, well, these words seem to be associated with this topic, and it starts from that, building over time, running over and over again, a mapping between patterns of topics and words that seem to indicate the topic, a number of records that are associated with that. And by doing this, it's learning, so it has to do with seeing these patterns, seeing many records over time. It starts to get good at identifying those hot topics that then we see in our maps. And some things that are interesting to note, because there's not that much that you can do to fine-tune this, other than you can define stop words that are irrelevant, so that you have a cleaner analysis. But other than that, here's some numbers that you may want to be aware of. If we have fewer than 50 records that we're looking at or analyzing, there'll be we'll still try to find at least 3 topics that seem to be the most common. As you increase the number of records, let's say 50 to 100, now we have 10 topics all the way to more than 1,000 records. There may be 40 different topics that can be found. And so you can see how that varies, but you need to have at least 20 records for hot topics to find anything of interest. And then the number of topics, the number of words in each topic will typically be 3 to 4. So that's when we see the pattern. I don't know if I have a screenshot of a topic, but it'll be, let's say, network disruption or printer out of paper. 2, 3 words together become a topic, and then that's now chosen as a label for the hot topic area. And then each hot topic area could have subtopics as well. So, when we talk about having 40 topics, you have top level and then sub levels, and together they become 40 altogether. And you have that only present when you have enough numbers where we have a significant level of subtopics based on these numbers that we see here to show that again. And in general, the way this works, by the way, we clean some irrelevant data from text, such as HTML tags or dates and numbers. We remove common or very rare words. If a word is too common everywhere, it's irrelevant, or a word that only occurs once, obviously it's not a hot topic. And then, stemming can make words that are, really part of the same family. Computers versus computer, calling or call. Well, let's associate as being really the same stem word. And then you have control over defining stop words that just ignore these altogether. We'll see how those are configured in a moment. And then we identify the hot topics. So that's it. I'm not going to go into the use cases of hot topics, but if you're curious about how to use this, if you haven't used them, there are some primary use cases in knowledge management, proactive problem management, analyzing surveys, all kinds of useful ways of using this data. Next, as far as virtual agents, some things to mention here. Actually, I will only talk one slide to this because some of this is referencing, again, things that we started in our data and will be coming in the next version. Some of you might be in our design partner calls on virtual agent, or if you're interested, we will have some more in the coming months as we make progress. But there's a number of technology that's being incorporated here. It's unstaged over time, so not everything that I show here may necessarily be in the very next update that we see. But the whole idea here is learning from different sources. One area is this way of learning, small talk, kind of like how do people use language and how to interact with someone in an interesting, chatty way. We're not applying this yet in what we're coming, but it's one thing that we are POCing or considering internally. Seeing what's common and frequently asked for or searched for, and then making suggestions for that is something that we do in our virtual agent today. And then learning from existing content, like knowledge articles or catalog content, and from that being able to suggest them or automatically request them is something that we'll see. It's a big focus of what we're doing on first. But then over time also just learning over existing chat history, the adaptive learning on feedback that we get on what is useful or not useful based on conversations that have been had, that will be key. And then last but not least, sometimes the technology enables a more structured approach to teach, rather than automatic learning. How can I teach a system something? And we'll provide an interface for actually teaching about intents that people want to chat about and different ways that an intent may be identified. And with some manual teaching, that will become intelligence that now the virtual agent has. So sometimes you can learn very automatically and independent of any administration type of intervention. Sometimes you allow that administration. We'll see some of that here. And speaking of that, I do want to talk about some other configuration and administration things that are key to know related to a few of the areas of technology that we've talked about. And there's configuration settings in a number of different areas in the product that may be relevant to some of these search or smart ticketing or machine learning type of features. First, from a tenant administration perspective, this is, and each tenant by tenant, there are some features that allow you to configure smart ticketing, like what we looked at before for defining your training and testing samples and the configurations. And there's also configuration for smart search. I think I have a screen of that here in a moment to configure some best ways to fine-tune areas of search. I'll show those here in the screen. And then at the suite administration level, this is more for your whole farm, all the tenants. There are other important administration tasks that are important to know about. I mentioned them here, at high level because there's documentation for all of them. So here, you'll have the slides, and here's a link to the reference for a lot of these things that allow you to configure the way that search or smart analytics work. I'll talk about each of these just briefly. One that you see here is scaling out the DAH component. This is really more about making things scalable and high performance. As you can imagine, anytime you're involving these algorithms, let's say for global search, smart search, that can be performance consuming. And so it's important to know of the tools that you have. We have specific idle services that we use for our smart search, with which are load balanced to be able to take in the amount of indexing and searching that you're doing in the system. And sometimes you need to scale those out when you need to have higher performance of your search. You have more users on your system, number of records is increasing. So as a farm administrator, you have the ability to scale this out. And again, there's documentation how to do it. Some more details here. We don't need to read this fine print right now, but that's an important thing to consider. There's another part of scalability also for search that has to do more with scaling out, especially as the number of records that you're indexing is growing. So it's important to know that within our search technology from IDLE, there is what is termed as a content group that clusters the data that you're indexing. And the recommended maximum here is to have up to 2 million records per these content groups. And within the suite administration, there's a screen, again, all reference to the documentation, but it will tell you what your capacity is. Let's say out of the 2 million records, we hired just 152, so we're very low. So far, we have a lot of space yet in that content group, but as that gets maxed out, you can add more content groups. They get created for the indexing, and then you can scale out and index further. But that's something that as an administrator you'll want to monitor and add scale out grouping as needed. And then also within the suite administration, there's a number of different debugging tools, monolithic assistant tools. If you're not aware of these, again, look more details in the documentation, and you can come into the suite administration to see, for example, all the services that are running. You can also run things to determine the kinds of queries that are taking place for search and finding out the results or accuracy or match accuracies of different queries. So it's something that, because of the scope of today's call, I'm not going to go into that, but it could be a follow-up for another practitioner forum. How can you determine, why is a certain search giving me results or not giving me results? There are types of actions you can take in the assistant that will enable you to look at that. Another thing to be aware of is defining stopwords, as I mentioned, for hot topics. So this is key for being able to have more accurate hot topics. Here's examples of words like about or and, because, could, or maybe names that you don't want to have show up. You define them as words that are ignored. You can define synonyms as well. This is very useful for smart search, so that you want searches for something, somebody searched for excellent, and somebody for wonderful or marvelous. All these are synonyms. So if I search for marvelous, but a document has the word excellent, let's have that be a match. And this is especially important where you may have, let's say, names for internal systems that people call by their name or by another name. So put them as synonyms, and the search will find matches based on that. Very useful fine-tuning tool to apply. And then the slide, you get the details on how to put the synonyms. You can read those and try them out. Another thing that helps too is defining index weights for fields like the title or description fields. So there's a section in a CSV file used for defining smart ticketing search parameters that lets you provide higher weight for these fields, and by doing that, you have the ability to have a match that's in a title or a description be higher than something that matches other places in the record of something that's, let's say, in the catalog content. Last but not least, it's something that's important too in terms of search, and this question I know comes up often, is when I, let's say, introduce a change or a new record into the system, or or a modification to a record, how quickly will that be available for search? How quickly is the index? Is it instantaneous, or no? It actually seems sometimes to take, let's say, 8 minutes. It seems, and the truth is that there's a few factors that determine how quickly the record will be indexed. First, we have an interval that takes basically any time a record is modified or added, we will put that into a queue that IDLE then just keeps. Here's a queue, and these things will be indexed at some point. And And so we update that queue by default every 60 seconds. But there is in the Suite Administration UI, as you go to the Analytics section, you'll see where you can say, well, I want to change that. Let's say I want that to happen every 10 seconds. And so every 10 seconds, that queue will be updated. And then you may expect, okay, that means that as soon as I change something, maybe I'll search and 10 seconds later I'll see it. And then the answer is no, that's not necessarily the case, because there's another factor that happens. The queue is being updated, maybe every 10 seconds we add things to the queue, but then there's an interval that IDLE uses to say, okay, I'm going to go now look at the queue and do a new index so everything's in there. And even if I was adding things every 5 seconds to the queue, there's this other interval that says after, let's say, by default, 8 minutes, that queue is looked at. It has grown over the last 8 minutes, and then everything is sent to index. And so that's a max sync index delay that's in the content CFG file that you can update for your indexing. And so you may say, well, I don't want to wait 8 minutes. I want to do that every 30 seconds or every minute. And you could try that, but of course, these things have a performance cost. So we have it at a default based on just what we know will be good for performance, based on sizing, number of records, the type of infrastructure you have. You may get away with having a much smaller value. And this is something that you can discuss as far as best practices. But we've incorporated, doing some tests of having smaller numbers here. I believe that 8 minutes has been overly conservative or sized for a very large a deployment that has a very large number of tenants and a very large number of users. But I think for the average case, you could have a much smaller interval there that would also work. But we haven't published new numbers and new tests, but that's a forthcoming exercise we need to do, so we can give you a best practice. But just be aware of these things, and we can interact with those of you that have questions about it to change your indexing. And here's more information, of course. You can always force a full reindex, which it's not something you'll be doing all the time, but this is something that can be manually done, and there's a reindexing tool. There's a link here on the slides on how to do that, and information on that. And that's it. I think this last slide just shows that screen that I wanted to show on the Analytics settings, where you can also fine-tune other things about your searches for ignoring certain special characters or phrase queries. Just be aware of this as well, and we can fine-tune that in further drill down, because I know we are just now 3 minutes over the time here. So with that, I apologize we ran over time. I appreciate everybody that's been on the call. I know a lot of questions have been put into the comments, and we will be looking at those questions. Some have already been answered here live, and then we can publish the answers as well, together with a recording. And Bendusa or Tanya, anything that we want to add to close before we close? No? Okay. In that case, thank you, everyone.
There is only one question that came in, and it's about exactly the 60 seconds plus 8 minutes. Apparently, Carol is saying someone told her it's 5 minutes, but I think this is the maximum, right? I mean, things can happen a bit earlier depending when the record gets added to each of the queues, but these are the numbers from the configuration.
Yeah, and thank you for saying it's the maximum.
And I think there is a myth. Sometimes people just there is a rumor or the number that's sometimes floating around about the 5 minutes, but it is 60 seconds plus 8 minutes, and it has been like that in I would say Service Anywhere as well.
Yes, you're right. And let's say that you made a modification just at the 7 minutes and 50 seconds before the next reindex. Then 10 seconds later that may show up. But so things will average between 8 minutes and a few seconds. So maybe there's an average of every 4 minutes something shows up, but it could be a maximum and a minimum. to consider. And that was the only question? Okay.
Yeah, that's the only question that came in. So thank you very much, David, for this great presentation. We'll wrap up here. David, I think you can stop the recording.
Okay, yeah, thanks for reminding me.
And, we'll look forward to seeing you in one of the next sessions. Thank you.